This video is on the objective calculate a confidence interval for a population mean, but with the population's standard deviation unknown, right? Sigma is unknown, meaning you're going to be finding, a t-score to help you figure out the margin of error instead of a z-score, right? And you're going to be dealing with that student's t-distribution, and every student's t-distribution, depends on the sample size, right? The number of degrees of freedom depends on the sample size. So you've seen this already. This is my second video, right? Number 2 on this particular objective. So this is gonna be a little quicker than the first one. Not gonna go. I'm just gonna show you the formulas, plug some stuff in, show you how to work this, and figure out a confidence interval estimate for the mean. So here, the question I'm looking at here: suppose that the length of unemployment for laid off workers is normally distributed with an unknown mean and unknown standard deviation. So a random sample of 33 unemployed workers is taken and gives a sample mean of 90 days before securing a new job, right? 90 days of unemployment is the average number of days that these 33 unemployed workers were on unemployment. And a sample standard deviation of 10 days, right? So we have x bar 90, we have s 10, and we have n sample size, right, 33. And notice again they're giving us a table here with degrees of freedom and particular t-scores, because we're going to need to find a special t-score, right? How many standard deviations above and below the mean are the upper and lower values of a confidence interval. That's what the t-score tells us. T-score is just like z-score. It's a number of standard deviations away from the center. So again, all we're asked to do in this first part is find the margin of error for a 90% confidence interval estimate of the population mean using the student's t distribution and round to 2 decimal places. So we're trying to guess, right? That's what a confidence interval is. It's a range of guesses as to what the population mean is. What's the average length of unemployment for all laid off workers, not just this sample of size 33. Okay, so if you recall, when we're making a confidence interval, right, I'm going to use CI for confidence interval, right? When we're making a confidence interval for mu, right, for the population mean, with the population standard deviation unknown, our margin of error formula was the following, right? We had to find some sort of t-score, right? Not z, t. Some sort of t-score with an area of alpha over 2 above it. Remember where alpha was just 1 minus the confidence level, right? Or 100% minus the confidence percentage. And then half of that, what t-score has an area of alpha over 2 above it, times the standard deviation for the means, right? The standard deviation for the sample means, the x bars. Now normally, right, when sigma was known, that was sigma divided by the square root of n. But we don't know sigma. So we're going to approximate that with s, right, the sample standard deviation. So we take this number of standard deviations, multiplied by the standard deviation of the x bars. Right, s over the square root of n. And again, this t here has n minus 1 degrees of freedom, right? df for degrees of freedom. All right, so we're given here in our particular question, the sample size is 33. All right, so that means we're looking at a t distribution with 32 degrees of freedom. Right, we're looking at a student's t distribution with 32 degrees of freedom. The sample mean, right, those 33 laid off workers, unemployed workers, had an average unemployment time of 90 days, right? So this is our point estimate, right? This is going to be the middle of our confidence interval. And the sample standard deviation, right, the S, that we're going to use to approximate sigma is 10 days. So S is 10. Alright, so I have pretty much all the information I need. I just need to know what this alpha is, and alpha over 2. Now we're asked to create a 90% confidence interval. Right? So we have a 90% confidence level, meaning that alpha, right, the value of alpha is what's left over. Right? If you got 90% in between the upper and lower value of the confidence intervals, then what's left over is 10%, or as a decimal, that's 0.1. So this alpha over 2 is 5%, or 0.05. So we're looking for t-scores. We're looking for the t-score that has 5% above it, and then the opposite of that would have 5% below it. Right? We have 90% in between these t-scores. Right? We have 90% of the area under this curve between the upper and lower value of the confidence interval. So that means there's 5% above the upper value and 5% below the lower value. So we're looking for the t-score for a t-distribution with 32 degrees of freedom and 5% above it. So our margin of error, right? Margin of error is this t-score with 5% above it for a t-distribution with 32 degrees of freedom, multiplied by the standard deviation of the distribution of the x-bars, which is approximated as 10 divided by the square root of 33. All right, so I'm going to find this from our chart. Right. So go back here. Like I said, there were 32 degrees of freedom, so I'm looking at this row. And we're looking for the t-score with 5% above it, t.05 here. So 32 degrees of freedom, t.05. It's 1.694 standard deviations above and below the mean to get our values, upper and lower values of the confidence interval. Right, so the margin of error is 1.694 standard deviations, and I will find this. Right? So this is 1.694 standard deviations, right, times 10 over the square root of 33. And we're asked to round to 2 decimal places. So let me enter this in a calculator here. Clear this out. So 1.694 times the standard deviation of the x bars, 10 divided by the square root of 33. And to 2 decimal places, that'd be 2.95. Okay. So there's the margin of error. Right, that's going to be the distance between x bar, right, the middle and the top of the interval, and the middle and the bottom of the interval. All right, so margin of error to 2 decimal places is 2.95. Let's submit that. Now I know there's a second part where they actually ask you, okay, now that you have the margin of error, what would be your 90% confidence interval estimate for the population mean, right? For the average length of unemployment for all laid off workers, right? The whole population of laid off workers. So again, they go through the same calculation I showed you there a second ago. Please, always read your answer explanations, right? Especially if you're wrong, just to make sure you figure out where you went wrong. All right, so they find the margin of error there, and then the second part, they're asking you, okay, what is that 90% confidence interval? So we're saying we are 90% confident that the true population mean lies between, and then let me show you how to form that. Right? So our 90% confidence interval, 90% CI, and you're taking your point estimate. The first estimate of the mean would be x bar, and subtracting the margin of error for the lower value, and then taking that point estimate, x bar, and then adding the margin of error for this upper value. So taking 90 minus 2.95, that'd be 87.05 for the lower value, and then 90 plus 2.95, this margin of error, so 92.95. So what we're saying with this is that, based on this information given, we're 90% confident that the the average number of days all laid off workers, right, the entire population is unemployed. The average number of days, all laid off workers are unemployed is somewhere between 87.05 days and 92.95 days. And I'll enter these values here, right, between the lower value, 87.05, and the upper value, 92.95. Wonderful. All right, and that's looked like the only other question from that objective, so I finished it. Notice the confetti. All right, so again, read your answer explanations, right? They show you how to calculate margin of error again, and then just, hey, remember, take your sample mean minus the margin of error, sample mean plus the margin of error to get your confidence interval estimate of the population mean. All right, so again, hopefully these videos help you out when you're working on this problem on your own, and these kinds of problems on your own, and thank you very much for watching.